Step synthesis route for ethyl ethanoate. A mechanism for esterification reaction. Ethanoic acid reacts with ethanol in the presence of concentrated sulfuric acid as a catalyst to produce the ester ethyl ethanoate. So here we have ethanoic acid, ethanol, and we put in concentrated sulfuric acid in an this is a equilibrium, so the reaction can go the same way for both of these. This then creates ethyl ethanoate as well as water. So water and ethyl ethanoate mixed in with H2SO4, dependent on the concentration rate and the concentration, it can shift the equilibrium to this side, giving more product on that, or dependent on giving more product with the H2O, or this as well. It's dependent on how much yield or concentration of these two products and these two products that are given out. This I'm not too sure. It's step 1. Ethanoic acid takes a hydrogen ion, which is positive, it's a proton, from the H2SO4 sulfuric acid. The ion becomes attached to one of the lone pairs on the oxygen, which has 2 lone pairs of electrons, which is double bonded to the carbon, which makes it 2 lone of pair of electrons and a carbon there. Yeah, so this is what the structure and the formula look like. Here we have CH3, carbon double bonded with oxygen. It's ethanoic acid. This is the structure of ethanoic acid, then giving its electron to hydrogen here, it taking the hydrogen, the positive proton, the proton switches with that, and then it creates this in the ethanoic acid. It creates OH and another OH. So they both look symmetrical, and the positive goes to the oxygen here, which then would, in step 2, would go back down to the carbon atoms. So what's left with the sulfuric acid is it having no hydrogen, and it's left with pairs of electrons with the oxygen atom. So the positive charge is then delocalized. However, this positive ion shifts to the carbon, which then produces a third structure. This third structure here is CH3, C double bond O with the plus with the proton, and HOH here as well. This then moves over to here. Oh, wait, no, this was from here to here. So this is the third structure. This would then make CH3, C with the positive. Yes, this would make this. Wait, it would just be one line here, but this here, because it's removed the double bond from here, it's removed that, but it's given its positive ion to carbon here, so they're both just single lines. And then if I can just try to you see this here. Anyways, CH3 to the C, the carbon, to O, to H. Where is the positive ion? Oh, right here. Because it's made its double bond with this O, because it passed down its delocalized charge to here. Yep. Okay, step 2. The positive charge on a carbon atom is attacked by one of the lone pairs on the oxygen of the ethanol molecule. So here we have the same molecule that we were looking at before, where a nucleophile is attacked by on the carbon here, which connects to this part here. So in this step, this ethanol molecule comes into contact with this ethanoic acid, where it attacks the positive part on the carbon because it still contains its ion. I'm not too sure if I got that right. Bear with me. Oh yeah, so this step is from the previous step. We're just basing it off of this one here, so we can get a connection with ethanol molecule. This ethanol molecule will then create this structure. In step 3, the hydrogen ion gets transferred from the bottom oxygen atom to one of the others. It gets taken off by one of the substances in the mixture, then placed onto one of the oxygens. This is a net effect, built like a net. The proton gets transferred to the hydrogen ion, and it gets transferred onto here. Here we have the positive ion on the O, because from before it attacks here, giving its one electron from the pair to here in order to get the positive ion. So this positive ion then gets transferred to this oxygen here, as this is connected to C and H2. So this doesn't no longer need a positive ion because it doesn't have a hydrogen here anymore. So it will leave this with a lone pair of electrons. So just this doesn't. Yeah. So the oxygen would then have its proton here because it has it would make it more positive in order to gain more like another connection elsewhere. So molecule of water is lost from the ion. So this part here, because it's partially positive, it would break from here, leaving this as H2O. 2 hydrogens, 1 oxygen, therefore it's water. So this H2O molecule would then leave this carbon positive because it had the positivity here, which then breaks this last bond between it, because it's not a double bond, it's a single bond. This positive would break this apart. So this is what would happen. CH3, carbon, OH, with another OCH2 and a CH3. Just like how it says here. Just here. With the H2O. So, if I turn over. Step 5. The hydrogen is removed from the oxygen by reaction with the hydrogen sulfate ion, which was formed in the first step. Okay. The ester has been formed and the sulfuric acid catalyst has been regenerated. So, CH3, C plus to the O, and a hydrogen here. This hydrogen will leave, and leaving this more negative, making it more bonded. So it would be a double bond here. So this O, oxygen atom, and CH2, CH3. This is left. Because with the sulfuric acid, it wants its hydrogen back. Therefore, it's going to complete itself in the first step like before. So in the reaction, it will happen where CH3 is connected to carbon, which is then double bonded to O, which is then connected to another O, and is connected to CH2, CH3, leaving sulfuric acid complete and fine. Afterwards, I will complete this later on. Thank you.